everyone, and welcome to this episode of AWS for Games Workbench, the program where we demonstrate how game developers can jumpstart their game development journey on AWS infrastructure by simply following along with our episode experts. My name is Chris Melisinos, and I'm the Principal Evangelist for Video Games at AWS. And on this episode, I sit down with Juho Jantunen, a Principal Solutions Architect at AWS, to demonstrate how any game developer can build a game backend framework on AWS quickly, easily, and cost-effectively. Links to all the materials discussed in this episode will be made available in the description below and listed at the end of the episode. So, speed is the goal here, so let's jump right in and meet Juho. Hey everybody, I'm sitting down with Juho Jantunen, a Principal Solutions Architect here at AWS, focused on AWS for Games and game-related customers. And I'm super excited about this episode because we are going to be walking through today how a game developer that has never touched AWS services before can stand up a game backend on AWS. And we're going to try to do this in a way that makes it a lot of fun, makes it fast, and clarify some of the mystery of standing up these types of services on cloud services like AWS. But before we do that, I would love, Juho, for you to introduce yourself to our audience and tell us a bit about your background and the work you do on the daily here at AWS.
Yeah, thanks, Chris. So great to be here. As mentioned, my name is Juho Jantunen. I've been with AWS for a bit over 4 years now. And always focused on games customers first for the first few years in Europe, now moved to US and in a more global role. Basically, the team I'm in, we build solutions for our customers and also support our AWS for Games field teams around the world to support their customers on game backend architecture. So this includes game backend systems as well as game server hosting. Those are the things I'm focusing on. I also have a long history in the games industry myself. Started, I think, about 14 years ago, making games, and I also was in that spot of I don't know anything about the cloud, but I need to build a game backend. So I've been through that, and this is one of the reasons we built the AWS Game Backend Framework to simplify the sort of getting started process on building game backends in the cloud.
Yeah, and having somebody with your experience, right, building games before then coming into AWS, like many of us here, right, in that focus on AWS for Games, come from the games industry. It's really important because AWS, being the largest cloud provider in the world, has thousands of different features across, hundreds of different services. So it's really important to understand which ones are going to be most important, which ones are most effective to achieve the needs for modern game development. And so today, what we're going to do, so Juho is going to run us through standing up that game backend on AWS. And we're going to go ahead and try to speed run this a little bit, right? Being gamers, we're maybe we should try to do a speed run. So the goal here today is to demonstrate how you can follow along with Juho and stand up, again, that AWS game backend framework in 30 minutes or less. So that's the goal for us today. And I've got my timer here so I can go and start the countdown here. So what we're going to do is in a moment, Juho is going to basically set the stage for how you would start to build, again, that game backend on AWS. And so Juho, why don't you walk us through the initial setup steps before we start building that backend game or utilizing that backend game framework?
Yeah, sure. So I pre-set up a few things. So first of all, we're going to go through a workshop that is publicly available. So you will have the link available for you. You can follow the exact same steps yourself. I've only done one thing. So I have something called AWS Cloud 9 deployed. The workshop has basically a way for you to deploy this directly from the browser with a few clicks. But I pre-deployed it because I wanted to change some of the font sizes and stuff like that. So I cheated a little bit, skipped the first 5 minutes. But literally, I have a fresh AWS account. The only thing I've deployed is the Cloud 9 IDE. So this is like a development environment in the cloud. The good thing about Cloud 9 and the reason we're using is that it has all the tools pre-installed that you need. So you don't need to install anything. But obviously, you can do this in your local environment as well by installing things like AWS CLI and some of the other tools that we're using. And on the framework, you'll find there's a setup phase. So you'll have instructions on how to do this on your account. We have that sort of pre-set up, and we're going to start from the first step of deploying the solution itself.
Okay, so now you've set up your AWS Cloud 9 environment. What are we doing next? And tell me when I need to start this. Tell me when I need to start that stopwatch. Tell me when we're going to go ahead and try to do this in 30 minutes. Are we starting now?
Right. Let's start now.
All right, here we go.
So I followed the first step. So first thing I'll do in Cloud 9 is I clone the repository. So the solution is available open source on GitHub. I cloned the repository here and I have it now in my Cloud 9 environment. Once I've done that, the first thing I need to do is do some initial setup. And I'll because we're on a speed run, I'll get it started and talk to you through it. So we're using Cloud Development Kit. So this is a toolkit that you can use to manage all your cloud infrastructure with basically with code. And we're using TypeScript, which is the sort of the default language, but there's other languages available. And what I need to do in the repo is that I go to my identity component folder. I install the dependencies for Cloud Development Kit or CDK, and I bootstrap it. So the next thing that is happening is the bootstrapping. This will set up like an S3 bucket, which is our object storage for managing our backend assets. And after that, we can get started by deploying the first component. And the first component is the identity component. So this is a critical piece of the framework. So we have a support for cross-platform identities. So that in the component supports things like guest identities, Steam identities, Google Play, signing with Apple. So many of the games platforms that you need, and you can also add other ones.
Oh, so this part allows you to go in and connect to those different identity systems for your endpoint distribution or where those games may have been downloaded or the identity of the players that will be on your server. Is that correct?
Yeah, exactly. So you can do crossplay. You can have a user that is starts with a guest identity, maybe signs in with a Steam identity, links a Facebook identity, plays on their mobile, so you can really implement that cross-platform play.
Excellent.
We also have sort of game engine SDKs to support that as well. I'll make sure that I start the deployment. So we're using CDK as discussed, Cloud Development Kit. So it's a single line of code to deploy the identity component with the default. So we're going to deploy it with guest identities supported. So I'll get that deployment started. This is probably the longest one of the speed run. So it'll take something like 15 minutes. So we'll have plenty of time to discuss what's happening and also like how the identity component works.
Okay, so the services that you're using right now again are Cloud 9, S3, and what else?
Okay, so let's look at that. So in the workshop we have a few architecture diagrams. Let's scroll down a bit. So this is the backend API, and I can walk you through this. So we have SDKs. So we have SDKs for Unity, for Unreal Engine 5, for Godot. It's also REST API, so you can integrate with your custom C++ engine as well, for example. And the SDKs come with the backend framework, and you use them to connect to the identity component. And the first thing you connect to is an Amazon API gateway. So this is a serverless service that manages APIs for you. So you have things like login as guest, refresh access token, login with Steam, APIs like this deployed. And we're just using guest identities, so we have only these API endpoints, login as guest and refresh. And the API is also protected with AWS Web Application Firewall. So this is a layer 7 firewall that manages things like protecting you from things like cross-site scripting or too large packages. And it also has rate limiting rules built into it. So we're using all of that good stuff with the layer 7 protection here. And then the requests go from API Gateway to AWS Lambda. And AWS Lambda is our serverless compute platform. So basically, you just upload your code, and we distribute it horizontally on multiple execution contexts, so you can scale to like a lot of concurrent users. But you don't need to manage the underlying infrastructure. So using serverless heavily on the identity component here. And we have two endpoints. So the first one, your SDK will connect to from your game engine is login as guest. And it will create a guest identity for the user. So it will be created in Amazon DynamoDB. Again, another service. This can be sometimes frightening, so I'll walk you through it. So Amazon DynamoDB is our serverless NoSQL database, and it's very, very scalable. It's used by many games customers, but also customers like Amazon.com, which have like a super high throughput of traffic on Prime Day and events like this. So Amazon DynamoDB will store in this NoSQL database, serverless NoSQL database will store the player identities, the user IDs, the guest secrets, linking to other identity providers. And then another service we're using is AWS Secrets Manager. So this is the place where you can store secrets. And we're storing the private key for signing tokens for the client to access backend services. We're signing a JSON web token on the Lambda function and sending the token back to the client so they can then connect to backend components. We're going to deploy those later, so we're not doing it at this point.
Okay.
And the backend components can then validate that identity to securely connect to your backend with an authenticated user.
Awesome. Great. All right, so that's the core architecture, and that's basically describes the different services that you as a game developer would utilize on AWS to build, again, this game backend, utilize this game backend framework. So why don't we jump back on over and check in on the status of your...
Yeah, let's see where we are.
Okay.
So there's one, actually, we're going to be stuck here for a while. So one component that we're going to be deploying is an AWS Cloud from distribution. So this is basically an endpoint that is cached in our edge locations around the world that is quickly accessible. And that actually, while that's deploying, we can talk about another sort of feature of the identity component.
Great.
So another thing we have here is the management of the keys. So when you want to securely access a backend, you need a system that obviously identifies the user, they log in, and generates a token for the client that it will be then sent to the backend. And the way this works in the framework is that we have, again, a Lambda function that is running on a weekly basis. So we're rotating the keys on a weekly basis. And it will do two things. So it will generate, first of all, the JSON web key set for signing the tokens. It will store the private key in Secrets Manager here, and it will store the public key in S3. And the Cloud from distribution basically just gives an endpoint for your backend systems to access that public key. So when they get a token, they can validate the token with the public key. So
let me stop you there and ask a question. Why do we go ahead and change that key out on a weekly basis?
So the rotation is actually it's something you can configure. So you might actually do it on a yearly basis. So even every 5 years. We just default it to 7 days because it doesn't add any complexity for us. And the idea is obviously that you need to have a way, like in a scenario where you just want to refresh the key, you want a new key, maybe your key was compromised. It's like, obviously we've done everything we can for that not to happen, but you need to have a way to rotate the keys if you want to. And it's a standard way of building sort of identity providers in the cloud. So
and
we
it
just
provides
default to 7 days, but some systems, some of the integration points, for example, maybe rotate every year or every 5 years, so you can customize them.
Sure. And so this just adds another layer of security. Like you said, if a key was compromised, then it kind of mitigates the amount of either damage or amount of time that somebody could use that to, exploit the server or to create, an unfair scenario in terms of gameplay or damage, right, the service. So having that functionality built in just provides another layer of security and protection for anybody deploying, right, on AWS using this framework. Right. Yeah, that's great.
And we're using a standard setup where you have the latest key and the previous key available. So sometimes you have a client sending the token side with the previous key. You don't want to lock them out, so you always have two of the latest keys in S3 available for the
excellent.
Backends. All right, let's see where we are. So as said, this is by far the longest wait. The thing is that when you deploy a Cloud from distribution, it will distribute basically endpoints in more than 100 locations around the world. So it takes a few minutes, but it seems to be done now. So now we're rolled through the rest of the stack. While we're doing that, we can actually look at what CDK deploys for us. So CDK is essentially a way to define your infrastructure as code in TypeScript or Python or maybe C#, but it will generate a CloudFormation template. And CloudFormation is the fundamental sort of infrastructure as code solution of AWS. So if we go to the management console, this is like when you set up an AWS account, you'll go to the management console. We can go to CloudFormation.
And so that management console will show you all the different services that you're authenticated to use, that you signed up for. So it's kind of that one-stop interface to manage all of the different services that you may be subscribed to or utilizing on AWS.
Yes, exactly. So here we see some of the predefined, pre-setup. So we have the Cloud9 deployment that I did beforehand. We have the CDK bootstrapping, and then we have the custom identity component itself. So this is the stack that the CDK tool will create and deploy. And it also, CloudFormation also manages the state of the stack. So when you make a change, let's say I add like the Steam integration to the system, I can deploy a new version of the app, of the backend, and it will only make the changes that are needed to the stack, and it will always know the state of it. So you don't need to go like through the console and click through things, and which is also a very error-prone practice. So everything can be managed through CDK and CloudFormation.
Very cool.
All right, so the stack is deploying. Actually, it seems to be done now. So as we're doing a speed run here, I do the next step. So the next step is to run the first generation of the keys. So we don't have signing keys yet, so we'll generate them once, and then it will rotate them every 7 days. So that's done. We got a 200 response. So we just basically executed the Lambda function that generates the keys, and they should be now available.
Okay.
All right.
These steps that you're following are all in this workshop that's then available to anybody at the link that we provided below.
You can just copy paste and follow all the exact same things.
Wonderful.
I'm not doing anything that magical here.
All right. So we created the first set of signing keys.
Yes. And now we are going to deploy some sample backend integration. So like starting points for you to develop your custom backend features, be they like player data management, leaderboards, chat, whatever you want to build. So we need to do one configuration to get started. So we're going to go to the backend. Again, it's a CDK application as well. So we're going to go to the sample backends. And we'll need to tell the backend components that what is the endpoint of the public key that they use for validating tokens. So that's the only thing we need to define here. And we got it as an output from the identity component deployment. So I've set it up, hopefully correctly. And once that's done, we can just go on and deploy the backend. So very similar process. We'll go to the CDK application, install the dependencies, and then we just run CDK deploy to deploy the backend. We actually have two sample components. We can talk about the architecture once I get it to the deployment phase. So we have a serverless component that you can get started with, and we also have a container-based component if you want to write like container-based backends.
What I also noticed as you're going back and forth between the two tabs is that in the workshop here, you've gone ahead and put the copied links right in there, so you don't have to worry about missing a character or something. You're making it really easy for anybody to come here, just click copy for the code block and drop it basically back into the interface, and
exactly
it just works.
So it should be pretty straightforward. So I'll start the backend deployment. We'll just make sure that it actually works, and it seems to be going fine. So we can look at the architecture a little bit. So on the backend side, we have two sample components. We can go through both here.
Okay.
So the first one is a serverless. So again, if you want to stay in the sort of the serverless realm and have everything managed for you, just upload your code. You use serverless databases, other serverless systems. You can start with this sample component. And the way this works is that you use the SDK that we provide. So you use your Unity or Godot or Unreal 5 SDK, and you make a backend request with the SDK. And when you've signed in as a guest user or Steam user, whatever the user is, you can make the backend request just by using the SDK, and we'll automatically send the headers and everything needed for that authentication. We have an API gateway again, so this is the endpoint that we're connecting to. The API gateway service natively supports validating JWT tokens. So when it receives the token, we configured it to call the CloudFront endpoint to get the public key, validate the token. If it's not valid, access is denied. If it's valid, it will send information back to the backend, which is again Lambda functions here, which contains the context like this is the user ID. Are they authenticated through an identity provider? Are they guests? So all this information will go to the backend.
So that handles everything. It handles everything automatically, so you never need to worry about a gap in checking for the authentication of keys, right? That's just built directly into the service, right?
Yeah. So only thing we provided is like, here's the endpoint to get the public key.
Right.
Here's the audience that you're using. So it's just features of JWT. We don't need to go too deeply, but it's just like it's game backend audience. And then you can decide if you support the guest users or the authenticated users or both.
Awesome.
And then, so the sample serverless component will have a get player data, set player data, and a player data DynamoDB serverless NoSQL database. So it's just like a sample CDK application that shows you that, hey, okay, you can authenticate, you can manage your players' data, you can set it, you can get it from the client, and then you can start modifying this to your needs.
Very good. And the advantage of using serverless, right, for people that may not have used a serverless infrastructure before, is that you only pay for the compute resource that you need at the time you go ahead and use it. So it's not like you're having to go ahead and provision systems that sit out there that may be cold, right, or not at full utilization. So service allows you to go ahead and grab the compute resources you need at any given moment in time, scale up to meet demand, scale down as the demand wanes, and you only pay for what you used.
Yes, exactly. So for example, for the identity component, we've done some load testing as well. So I simulated up to 2.5 million concurrent users from basically cloud resources acting as clients. And what happens is that the serverless compute platform will scale for you. So the Lambda functions, there's not only one copy of this. There can be hundreds and hundreds of copies running concurrently for different user requests. So it scales very fine-grained, first of all, and it scales to your needs. And you can get up to a very high volume of requests per second. And same goes for DynamoDB. So it will scale horizontally for you. So if you have, when you have your first test user, it will be scaled just a single partition. When you have 10 million users, it will scale out to multiple partitions, and you always get the same performance.
That's a problem we hope every game developer running on AWS has, right? To get to 10 million concurrents. How are we going to do that, right? So
exactly.
All right.
Let's see how our deployment is going just to make sure it's all is good. So we can look at the other one. So we're actually deploying two sample components. The other one is a container-based one. So we have an application, which is actually a Node.js application running in a container. We're doing this as serverless as possible. So we're using Amazon Elastic Container Service with AWS Fargate. And Fargate is essentially a service where the underlying virtual machine infrastructure is managed for you, and you just worry about the containers themselves. So we're deploying to Fargate. We have a set of tasks or service running on Fargate, which is our sort of Node.js web server. And we have the same features. So you can get player data, you can set player data, and it has its own Amazon DynamoDB table for that. So again, a similar starting point. If you want to go down the sort of containers route, you have a little bit more control. You can use different operating systems, whatever you want within the container itself.
Very cool.
And this goes to an application load balancer. That's our load balancing system. And in this backend implementation, we're actually validating the tokens on the service itself. So the service will validate tokens. We're using actually an open source package or library to do this that is provided by AWS.
Excellent. All right. So where are we in the process now?
Let's see. So we're deploying the Fargate backend or the serverless, the container-based one. I think I'll deploy the serverless one next. So a few more minutes. We can go to CloudFormation and see where we are. Actually, no, sorry. The serverless one is already deployed. So that's
great.
Done. We're a few steps away from the container version to deploy. And then after that, we can open up Unity and test out the integration.
Wonderful. All right. Yeah. So again, it makes it really easy to follow along with your deployment process. It makes it really easy to go ahead and use those code snippets that are in the workshop to go ahead and plug into the interface here. So again, AWS provides all the tools to build these pieces, to orchestrate everything together, and to manage them from a single control plane through that unified interface.
Yeah, exactly. So actually, if we want to be as fast as possible, we already have the identity component, we have the serverless component deployed, so we could actually spin up Unity already and just connect to it. And we can try the container ones as well.
All right, well, let's see where we are. We're at just over 19 minutes. That's
Okay.
not just
We're
even
doing
the
well.
deployment, but it's also all the explanation for the service too. You're doing a great job. Great job.
That's good. Okay. So to find the endpoints we need for our game client, I'm going to CloudFormation. So CloudFormation, the stacks will have outputs. So I go to the identity component stack and I'll go to outputs. And this is all described in the workshop, so you don't need to remember it. And I'll pick up the login endpoint. So this is what the game client will connect to. And I'll copy that login endpoint and I'll go to Unity. So what I have in Unity, and we have the same thing for Unreal Engine, we have the same thing for Godot. I've opened the sample project that comes with the framework. So I've done no modifications. This is a fresh sample project. I've just opened it and I've opened the guest identity and REST API backend sample scene. So we have some sample scenes that sort of guide you through the integrations. And I'm going to send the endpoint. So there's a game object that has a login endpoint URL, backend endpoint URL. So we'll set the login endpoint here. And then we'll need the backend endpoint as well. And we could use either one because both of these have the same features, but we'll get the serverless one. I'll just go.
All right. So to be clear, you are connecting to that backend component, the serverless one, directly from inside of the Unity IDE.
Yes. So this is like my game client connecting to the systems themselves. Okay. So we have login endpoint for the game client. We have the backend endpoint for the game client. And then obviously within here, we have a script that will use the Unity SDK for the solution to log in as guest, to make an authenticated backend request and print everything to the screen. So let's hope we don't get a demo effect and we'll press play.
All right, let's see. Requesting new identity, login response.
Okay, so it went through. We were lucky. So
no, not lucky. Good.
All right. So a few things. You saw that it was a little bit slow, right? So it took a few seconds to go through them. The reason is that we had nothing was running yet. Like we weren't paying for a single resource. So what happened was that it spun up the Lambda context to handle those requests.
Right.
So actually, if we run this again, it will reuse that context, and it's like massively faster.
Right. Okay, so let me ask you a question. If you are, all right, so, well, first of all, you basically stood this up from nothing following along your workshop. We finished that and demonstrated this at about 21 minutes in. So congratulations, you did it under 30 minutes, right, through this workshop. Anybody following along at home, right, can go ahead and pull down these resources, this information. We're going to have all the links to everything that Juho has walked us through today at the end of the episode here. And now you have this up and running. Now, as you explained too, because it's serverless, there isn't a server just sitting there waiting for these instructions. The very first time it happens, we spin all of that up on the back end, right? The framework is then now available to you. And so it takes just a little bit longer for that first one. But since it's up and running at that point, any other additional login will just happen basically instantaneously because the service is already up and running. And when nobody's using it, it all just dissipates. You're not being charged for idle services, right, sitting there running in the background.
Yeah, exactly. So all of this is pay per request. So you only pay for the actual amount of capacity that you're using. And then let's say we had like 10,000 concurrent users, all of them will be hitting the same API. There will be multiple copies of the Lambda context warmed up and ready to handle those requests.
Awesome.
Obviously, if you go with the Fargate, the container-based one, then you have those containers running. We also have scaling for that service, so it automatically scales out when there's more traffic. So it's a little bit different concept, but still has the same scaling, just like the containers are up and running for you.
Yeah. All right, so Juho, so you were able to demonstrate this getting up and running and then connecting through Unity. But as you mentioned, this will integrate with other engines, and because it's just using REST API, you can integrate this with pretty much any type of engine or service that you would want to go ahead and utilize on your own. So to work with the other engines kind of out of the box, where do we go to find out more information about how to do that?
Yeah, let's go through that. So we'll have the GitHub Repository link available for you. It's available in the workshop as well. And this is obviously where the backend framework lives. It's also an open source project, so we have some pull requests from the community, from game developers. So this is like, I encourage people to do that as well, and we're continuously developing it. So if we go to the GitHub repo, we'll have everything here. So this has all the documentation. It's a little bit more extensive than just the workshop. And it will have the documentation for the different SDKs as well. So for example, we'll have a Unreal Engine 5 SDK doc, Unity SDK doc, Godot SDK doc. If you go to the Unreal one, you'll find the instructions on like how the Unreal SDK works, how do you utilize it, some sample code, what are the public APIs, how you add it to existing projects. If you're adding to your existing Unreal project, it walks you through like the sample scenes that we provided for like signing in with a guest user, signing in with Apple, signing in with Steam, and the other systems. And all of the SDKs will have the same instructions here. And obviously the same goes for the identity component as well. So the identity component will have its own README that guides you through how to add the additional identity providers. So if you want to add your Steam app or your Apple app or Google Play app, and it also guides you through the API. So even if you did like a fully custom integration to your custom C++ engine, you'll have the API define what the requests look like, what the responses look like. So you can build that integration. And obviously, for a C++ engine, you could use some of the Unreal code that is written in C++ as well as an inspiration.
Excellent. So head on over to GitHub. Again, links at the end of the episode. And this will show you basically all the different examples that we have available there, how you integrate into those engines, introducing you to the concepts that Juho has laid out for us today. You can download the code. You can, because it's open source, you can be part of that community. So if your idea is how to go ahead and make it better and you want to contribute those back to, by all means, go ahead and do so. And that's why we have it living out there on Git.
Yeah, exactly. So as we have a few extra minutes, we can actually look at some of the stuff from the management console, just a few additional things. So now that we actually connected to the system, one thing you want to have is observability. So you want to understand like what's actually happening in my backend. And the solution integrates with Amazon CloudWatch, which is our monitoring, log management, distributed tracing solution. And one of the interesting features that we're integrating with is AWS X-Ray. So this is our distributed tracing solution. So if we look at X-Ray, we go to the service map, you will get a full map of the services and the integrations on the client, how the client communicates with them. So this reflects basically the calls we made from Unity to the backend system to request, to set player data, to get player data, to get an identity. And you'll see how the flow goes. So it goes from the client to API gateway to the Lambda context. Lambda happens to call DynamoDB and Secrets Manager. You'll get like request trace for all of these. You get the latencies, and you can really like dive into like where is that time spent when a request comes in. You can also look at individual traces. So you can look at, let's say, we made a request. Let's see, we'll find a good one. Made a request to log in as guest. You'll see like the request comes in, it goes to the Lambda context, which is then spin up. It goes through the code. It calls DynamoDB. We'll see exactly how many milliseconds we spend in DynamoDB, and you'll see the full request here. And you can see like, hey, I want to optimize something. You can dive into like really the details of the code. You'll get the log output here as well, and this even gathers logs from multiple systems. So you have the like API gateway logs combined with Lambda logs, and it's all like tracing the request all the way from the client to all the backend systems and back.
Okay, so this basically allows for the developer to see at every stage, every call that's happening, the time that it's taking, and can also surface some anomalies or issues, right, that you could then go and start to account for if you see kind of like, repeated issues that happen. So this really CloudWatch lets you basically dissect the entire chain of events from initializing to full execution.
Yeah, exactly. And that's like, and other things we have here is that we have some basic dashboards. So there's a dashboard that shows you some of the possible errors you would be getting in the backend. Typically, you wouldn't have metrics here, but you could create alarms if you start getting them. We'll have the logs. So you'll have logs for everything, all the different backend systems. They will be sent to CloudWatch logs. So you have the log streams from those logging requests from those Fargate backend systems, all of the different systems. And then you'll have metrics as well. So you'll have metrics from, you have lambda metrics, you'll have ECS metrics, you'll have specific metrics of the system that we call AWS for Games metrics here. So there's a lot of different resources that you can use to dive into the different, the performance of your backend in CloudWatch.
That's incredible. I mean, so AWS really does provide an extensive amount of tools for pulling together all of these different services, creating kind of these unified, frameworks, and then all of the tools to dissect, to observe, to understand how your application is performing, where there may be breakpoints, where anomalies may surface. So you get all of this again through that single plane of control, right, that AWS provides any developer that is signed up to use our cloud platform.
Yeah, exactly.
Amazing. All right, so let me ask you a question. So we've got this framework up and running. We're able to go in and connect to it from Unity. This is the jumping off point then, right? What can the developer do now that they have this up and running? Like, what are the next 2 or 3 things they may want to consider looking at, either building or tying into? How do they then go and utilize this backend that they've then now stood up on AWS?
Yeah, sure. So we can look at some of the configurations, some of the points where you would start adding your custom backend code. So the first one you want to look at in the repository is the identity component. So let's say you want to add your Apple app or Steam app or Google Play app. So to integrate with that endpoint, you'll go to the configuration of the identity component and you basically just add it here. So for Apple, it would be just your app ID here. You redeploy and those endpoints are deployed for you. So you can now log in with Apple. For Steam and some other systems, you might need to upload a secret. So we have guidance on like how to upload your Steam web API key. We don't want to like reference the secret directly in your repository. So that's not best practice. So we upload it and we just reference where the secret can be found. This is true for Google Play as well. And this would be your first configuration. So adding all those cross-platforms or multiple platforms to your system, and then your client can use their identities across these platforms. And obviously after that, you might want to customize this. So maybe you add another platform. It's another, like a console platform, whatever you want. You can always add new ones. So all the code is open source. So you'll find like the sample implementations for, let's say, login with Apple. So you could use this as inspiration to build another integration yourself and just modify the CDK app to then deploy that endpoint as well.
Great. So basically then, depending on where you want to deploy your application, this gives you the flexibility to choose which, storefront services, distribution endpoints you want to integrate into the backend. So you don't need to rebuild it for each one of them. You could just continue extending what you've already built here using this workshop to continue to add more endpoints for your content to live and find a new audience.
Yeah, exactly. And then finally, obviously, like we'll get to the backend itself. So the thing we see with games customers is that the features you build for a game backend are very custom. So you want to have they're very custom to your game. You have very specific features that you want to have on the backend side, how like the social features work or how players communicate with each other, how they trade items or whatever happens in the game. So you want to write that code. And that's why we build the framework the way we build it. So when you go to the backend components, we could go, let's say, to the serverless backend sample that we have. And we're setting player data here. This is the Lambda handler code here. It will get the user ID from the context. So the API gateway authenticates the user. We'll get the user ID here. We'll check that we have the right parameters available. And we can start modifying this. So maybe let's say we want to, instead of just storing user ID and player name in the database, we want to add the timestamp as well. That's a super exciting feature, but something we might want to add. Another thing I'm using here is AWS CodeWhisperer. So CodeWhisperer will actually generate code for us, so we don't need to write it. So I just added the comment, and it will just add the code for me. So that looks good. Looks
very exciting good. And practical use of an AI service, right? Is CodeWhisperer, to your point. Just takes that undifferentiated code, creates it for you, so you're able to go ahead and drop it in and continue on.
Yeah, and then we would like add the player stats or whatever. Like it could be something else that we want to add here. So, and then obviously you could build other components. So you could do a completely separate backend component that implements another feature, define the APIs in the CDK stack, CDK application, and deploy that. So you can have multiple backend systems. Maybe you want to integrate with some existing backend systems, so you can start modifying the code and then just continuously like redeploy the backend as you see fit. So that's basically where you would start modifying the implementation itself.
That's incredible. I mean, it makes this what can seem to be a very complex set, and it is, right? This isn't necessarily for the faint of heart, right? You're taking these very complex, robust services, lashing them together to create this environment, this framework for a developer, and following along again with the workshop, we're able to go ahead and get this stuff stood up right away. And the point here isn't to go ahead and tell you every possible thing that you can do with these AWS services. The goal here is to be able to jumpstart you onto AWS. So instead of combing through, 15 different white papers and documents and watching 8 hours of video, look, you want to go and get up and running, get a toehold in here and start understanding how you continue to build on AWS, how you can extend those services. This is a wonderful place to go ahead and start. And, Juho has designed this workshop for that very goal, right? To help people start building on AWS faster, more efficiently, kind of cut through it all, get you the features and services that you need. And I love the fact that you brought up CodeWhisperer. I think this is one of the most promising uses that we've seen of an AI companion for development, right? So really fantastic that we're able to demonstrate it here. And we'll have the link to that as well at the end of the episode.
Yeah, awesome. All right, I think we're done. So at this point, we will start just extending, building our own backend features.
Awesome. Juho, thank you so much for walking us through this incredible game backend framework workshop. And again, all these materials are available to you with links at the end of the episode, including where you can get access to the workshop, explanation on the AWS services that were outlined here today, links to GitHub and to the community. And yeah, Juho, thank you again so much for walking our developers through this easy way to go ahead and stand up and deploy that game backend and connect right into the engine of your choice. So really, really fantastic.
Yeah, thanks for having me, Chris.
Awesome. All right. Everybody get out there, start making some games. Can't wait to see what you're doing on AWS, jumping in using that game backend framework. So thanks again, Juho. Really good to see you.
Yeah, thanks.